When setting the particle color, I could initialize the color by using the color input of the emit splash from surface collision compound, but I might want the effect to be slightly animated over time using a combination of grays, medium grays, darker grays, and lighter colors closer to white. So I don't want to initialize, I want to be able to animate. So what I need to do is actually set the particle color by plugging into the terminal port of the ice tree and then modify the color I'm setting. If I use a color node, so if I just do a simple color, I could set the particle color, but the problem is the output is a color per object, and it doesn't obviously match with the inputs of the ports on the ice tree. I need a node that is of type execute, and the setters are great compounds that help in that regards. We could of course build our own compound, but a lot of these presets are here for us to speed up our workflow. So under task particles, I'm going to look under setters, and I'm going to set the particle color, which is, again, is essentially the same as this color attribute on the emission compound. So set particle color outputs type execute, but inputs an RGB value. So it accepts a color per object or per point of the point cloud. I'm going to plug the color into the set particle color, or sorry, I'm going to plug the set particle color into port 2 of my ice tree. And if we look at what happens, again, the default particle color is blue. So if I was to set it to something like red, let's just step through the graph. From frame 1, we have the particle color being initialized right away as red. So now to modify that color, I'm going to use a modify particle color compound. So if I look under modifiers, the modify particle color will give us access to a gradient that we can use to ramp the values over time. Modify particle color, again, is a particle color of type execute, so this won't really work in the color input. I can actually use modify particle color as its own execute port into the terminal node of the ice tree. If I did want to randomize the color by some kind of a gradient, I could pull in a gradient compound or a gradient node on my own. So if I look up gradient, I could pull in a Turbulize color by gradient, which outputs an RGB color, or I could use a simple gradient that requires an input. What I'm actually going to do is use the Turbulize color by gradient. You'll notice that if I edit it, it actually uses a turbulence node on the input of the gradient. So we have a Turbulize value by range driving the input of our gradient. And the Turbulize value by range is just turbulizing values between 0 and 1. And the reason we're using 0 and 1 is because 0 and 1 refer to the positions of the color swatches in the gradient node. So I'll delete my gradient. I'll delete my modify particle color. Modify particle color, by the way, is essentially just using a set particle color compound, and it's blending colors and choosing between a number of different cases here. So I'll turbulize the color according to the gradient. If I step back to frame 2, I'll just switch over into a shaded mode. You can see that we're choosing between a gradient of red and white randomly. So I just need to change those colors. If I start using some medium grays, and on the high end I have some whites, again I'll just kind of randomly pick colors here. I'll choose between 4 slightly different gradient colors. Maybe I'll add a little bit of a red tint in there, some red, rusty kind of earthy color. Let's tint that one a little bit, and maybe bring these values down a touch as well. Okay, if I draw my render region, of course we just get a solid color. So the next step is to go in and make the shape of the particles, the look of the particles, a little more appealing, as well as controlling the emission direction in a more creative fashion. So we've got our particle color working now, and our graph is starting to grow.